Hi there, thanks for joining us. This is a Q&A edition of Space Nuts. Not only do we talk astronomy and space science, we pretend to answer questions from our wonderful audience. We've got a bunch today. Bill is asking about small bodies in solar systems. I don't think that's got anything to do with weight loss, but we'll see. Peter is asking about leaving something behind that could survive the destruction of Earth. Wow, that's a what-if question. Tiny moons and giant planets and issues with a giant space station. Those are questions we will endeavour to answer today on this edition of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And with us again is Professor Fred Watson, astronomer at large. Hello, Fred.
Hello, Andrew. Fancy seeing you here.
Yes, unusual.
Yes,
Both wearing
yes.
black. Is it
Yes.
black?
It is, yeah.
Nice.
It's the this is the shirt that if I have Geordie sitting on my lap, you can't see him at all because it's exactly the same colour as he is, jet black.
That'll make a good Instagram photo.
Well, it might do, yes. Just two eyes poking out.
Now, we've got a lot to get through, so we'll start straight away with a question that comes from Bill. And he asks, if small bodies in the solar system formed by accretion of fine dust and gas, why are they not all fluffy, low-gravity powder puffs? Were all dense, stony, or metallic objects originally part of a larger body that could differentiate under decent gravity levels, then were smashed to small pieces in collisions? Thanks for the great podcasts. That comes from Bill. Why isn't everything puffy?
I think it was to start with.
Well, there you go.
Yeah, so people often say, people who should know better often say that if you want to know how planet formation starts, look under your bed because the bits of fluff that you tend to find under your bed are made of dust sticking together, usually by electrostatic forces, which we think played a part in the early evolution of planets. These things stick together. You build up bigger and bigger fluff balls, and eventually the fluff balls, because as Bill says, they do tend to collide with one another. We're now talking about a very, very dense, dusty environment. We're talking about the protoplanetary disk that surrounded the sun, very dusty place with lots of capacity for dust fluff balls to build up, to have bigger and bigger sizes. Eventually, these various forces will cause the dust balls to sort of collapse. Probably collisions will contribute to that. By that, I mean that they tend to lose their porosity. In other words, they become more solid. Now, having said that, there are objects in space that we know are very porous.
Well, we've found powder puff planets, haven't we?
Yes, that's right. Yes, almost exactly a good description of them. I'm just thinking more nearer to home, though. Phobos, the larger moon of Mars, is thought to have a composition a bit like God, the word's gone. Stuff that forms when eruptions take place underwater,
like a honeycomb.
Yes, but it's got a word. Oh, that's ridiculous. When you get to a certain age, words just disappear.
Yes.
It'll come to me in a minute, I know. But yeah, the stuff that floats on the water from an underground eruption. Pumice, the very word. That's what I was looking for.
Right.
Thank you, Andrew. So pumice is, it's porous. It's a stony structure that's got a lot of gaps in it. And I guess that might well be an intermediate structure of many of these objects. As I said, Phobos is like that. One of Saturn's moons, and I can't remember which one it is. It's the one shaped like a potato. That'll probably come to me in a minute as well. It's also got that sort of structure. So maybe, when you get things like that colliding, then and building up in size, then you're eventually going to get to this situation where gravity takes over and it pulls these low density materials into something more solid.
Is it a Malthea?
No, it's one with a better known name.
Oh.
It's very highly cratered and potato shaped.
Okay.
It's one of the most cratered objects in the solar system. I'm annoyed I can't remember it. It's ridiculous. I was getting too old for this, Andrew.
Oh, no, you're not.
No, maybe I'm not. No.
Keeps your brain active.
Well, except it's demonstrating quite clearly that the memory banks are disappearing. Anyway, it'll come to me, as I said, in a minute. It's not Enceladus, but it's something like that. So if you've got gravity taking over, then you're likely to get basically solid rock emerging from that. As Bill says, dense, stony or metallic objects. That's basically what they turn into. And then they collide. The larger objects are differentiated. That means the heavy stuff sinks to the middle, exactly as Bill says. But they collide, and that's how you can get stony meteorites or metallic meteorites, because the metal tends to sink mostly to the middle. So I think it is a natural process, but it's one, in a way, it's counterintuitive to us. How do you get from a fluff ball under your bed? How do you get from that to a stone, to a rock?
Gravity?
Yes, that's right, gravity, but over a long period of time, and probably heat as well. You've got heat processes coming into this too. So I think what Bill's saying is right. If the small bodies in the solar system formed by accretion of fine dust and gas, why are they not all fluffy, low-gravity powder puffs? Well, some of them are, and that's perhaps you could describe them like Phobos. Perhaps you could describe them as unevolved. They haven't evolved much. I think it might be Hyperion, the one I'm thinking of.
Okay.
I think it might be Hyperion.
I'll have a look.
Have a look, see if it's shaped like a potato and got lots of craters on it.
Yeah, well, there's got to be a photo of it somewhere. Yes, it is.
Yeah. Okay, good.
It's got that big. It's got a massive crater in it, actually.
Yeah, it does. Yes. Yeah. Yeah. So
you got there in the end, Fred.
In the end, it's just the processing speed's down a bit. I must be offline or something like that.
Probably need a reboot.
Oh, God, don't say that. It might never come back.
Well, that's happened. My car did that while we were away. Came home and to stop falling asleep, we decided we'd go and do the groceries straight after getting off a long haul flight.
Oh, yes. Yeah.
And the car wouldn't start. Yeah, the battery died. So.
Oh, the battery died.
Yeah, that's another $315. Thank you very much.
Yes.
Anyway, it happens. Yeah. It was 4 years. It lasted 4 years.
Oh, that's all right. That's about as long as you get from a battery, yes.
It is indeed. But thanks, Bill, for the question. I think you answered it yourself, but yes, although if you're someone like me and you don't clean under the bed, you can watch planets evolve. That's what's happening.
Yep, you can.
All right. Thanks, Bill. Our next question is coming from Peter.
Hello, this is Peter in Leamington Spa, and I want to know, what would it take for humans to make something that will survive the destruction of Earth and then potentially be incorporated into a new planet when all the bits of Earth become a different planet and sometime in the future?
Ooh.
Is it possible? Have a good evening.
Thank you, Peter. That's a what-if question. Yeah, I wonder, it's a long-haul science fiction situation. You build something that will survive the destruction of Earth, and then somehow the planet reconstitutes itself, and billions of years later, there's an intelligent race living on the planet, and they go, oh, hello, what's all this then?
this is some leftover of humankind.
Yeah.
Whatever they were.
There was a TV series that I watched many years ago called Childhood's End, and it was about the destruction of Earth. And before it was destroyed, the humans asked the aliens that rescued the children, basically, can we just leave something behind so they know we were here? So they left music.
Lovely. I like that. Yes, I like that very much.
I just spoiled the whole thing too, by the way.
I don't think you did, really. Because, yes, that's a kind of concept, isn't it, that you're leaving behind. And my mind, when I read Peter's question, or heard Peter's question, went to more concrete things, not necessarily made of concrete.
I was about to say that.
But in a sense, we've already done it, Andrew, because there are 5 little spacecraft which are absolute monuments to humanity leaving the solar system.
Yeah.
Way, way beyond the orbit of Earth. Voyager 1 is probably beyond... Actually, that's not quite true. I was going to say beyond the limits of the sun when it turns into a red giant star. Voyager 1 will probably survive the red giant phase of our sun, which will take place in a few billion years, 3 or 4 billion years. It'll survive that, but might not survive the formation of a planetary nebula when you've got hot gas coming off being puffed off the surface of the red giant. It might actually melt in that because planetary nebulae get to be light years in diameter. Our Voyager is only it's nearly a light day away. On the other hand, we've got 3 or 4 billion years to play with because the sun's not going to do anything really nasty within that time. So yes, Voyager 1 will be well out of the way. Probably will survive the eventual evolution and final evolutionary stages of the sun when it actually turns into a white dwarf star. So yes, those spacecraft, Voyager 1, Voyager 2, Pioneer 10, Pioneer 11, is that right? And New Horizons. They're the 5 that are leaving the solar system, which will probably outlive humanity.
And they probably won't be the last.
And they won't be the last. No, I think that's right. But I mean, the idea of the Earth being destroyed, the kinds of things that might destroy the Earth are, first of all, that eventual evolution of the sun to a red giant star. That will almost certainly melt the Earth because it'll, the sun's surface, put it that way, will be a quarter of a mile from the Earth, and we might be on the inside of it. It could even overtake the planet Mars. So it's hard to imagine how you'd rebuild the Earth from the debris that is really just molecules because it'll have been vaporized. So I think you've, in addressing this question, you've really got to think about things that have left the Earth, and that really basically pushes your mind to spacecraft. There are some spacecraft which are in orbit around the sun, which have spacecraft that have been sent exploring the inner solar system. Mostly these days we try and get rid of them. We plunge them into either Jupiter or Saturn. Jupiter in the case of Galileo, Saturn in the case of Cassini. Those spacecraft were destroyed purposely so that they didn't accidentally land on one of the moons of Jupiter or Saturn and leave microbes behind.
Yeah.
So you're really talking about something that's left the solar system, and that leaves those 5 spacecraft I've mentioned, and they definitely will outlast humankind.
Okay, there you have it, Peter. So we've already done it, kind of. I don't think you could probably build some kind of monolith or something that would survive the red giant phase of the sun and overwhelm Earth. That would all get destroyed, unless you did it deep down inside. But I don't even know if you could do that. I think a red giant phase would be pretty cataclysmic, wouldn't it?
Yeah. Yes, if your planet's being vaporized, your planet's being vaporized.
It is.
That includes the whole of it, yeah.
Indeed. Thank you, Peter. Great to hear from you. I love what-if questions, so thanks for serving it up. This is Space Nuts with Andrew Dunkley and Professor Fred Watson.
Let's take a little break from the show to tell you about online security with our sponsor, NordVPN. Now, you probably heard us talk about NordVPN before. They've been with us for a long time, and we really appreciate it. But there's a good reason for that. It's something that we actually use. Me personally, especially when travelling. In fact, last year when Judy and I were overseas, we ran into a situation where some of our everyday online apps on our phones just wouldn't work. Our banking app, for example, and that was crucial because we were actually selling a house while we were on a cruise ship. Yeah, don't ask. It was a strange situation, but we needed access to our bank accounts to make all that happen, and NordVPN was there for us. I even got to watch sport back home, even though we were geo-fenced out of the district because we were over in the Mediterranean or somewhere like that. So with NordVPN, I was able to log in and watch the football back home. It lets you securely connect through servers in your home country so your apps will behave like you're at home. But it's not just about access, it's about protection. NordVPN encrypts your internet traffic. So whether you're on public Wi-Fi or on your home network, your data is shielded from hackers and trackers and unwanted snooping. It also has a built-in threat protection system, which can block malicious websites and annoying ads and even prevent malware downloads before they happen. And setting it up, very easy. One click and you're protected across multiple devices, up to 6 devices with one service. Right now, if you'd like to take advantage of a special Space Nuts listener offer, you can head to this URL for more information, nordvpn.com/spacenuts to get 4 extra months free plus a 30-day money-back guarantee. They can't make a much better offer than that, can they? That's nordvpn.com/spacenuts, and don't forget to use the code word spacenuts. Secure your connection wherever you are in the world or the universe with NordVPN, our sponsor.
Listen, Tranquility Base here. The Eagle has landed.
Space Nuts.
Our next question, Fred, comes from Martin in Heswall. Heswall, is that right?
Yes, Heswall, yeah.
Where's that? I'm going to guess it's the UK somewhere.
It is indeed. It's on the Wirral Peninsula. So if you think of Liverpool, you've been to Liverpool.
I have.
And done the Beatles experience.
Yes.
Is that right? Yes, yeah. Well, across the River Mersey from Liverpool is the Wirral Peninsula.
Oh.
And Heswall is one of the towns on that. I've said before, and in fact we've had listener comments about this. I had a girlfriend once who lived on the Wirral Peninsula, and so I used to be a very regular visitor there to a village called Barnston, which was not that far from Heswall.
There you are. All right.
Yeah. It's very pretty too. It's a pretty village.
Okay.
She was a pretty girl.
Just wanted to know where you were, Martin, so thank you for that. I hope you'll answer this question. According to Wikipedia, there are now known to be 292 satellites with confirmed orbits around Saturn. Presumably, many of these moons are very small. So is there a minimum size for an object to be called a moon? And is there a minimum size for an object to maintain a stable orbit around a planet? As all the giant planets have ring systems, would the smaller particles just be absorbed into the rings? Conversely, I suppose that many objects could be knocked out of the rings to form independent satellites that may become permanently separated from the rings. Will Saturn get to 1,000 moons or more? Also, can you recommend a website which has the latest data about the solar system, as the numbers vary from one site to the next, no doubt due to how recent the information is? Keep up the good work. Thanks, Martin. That's a good question because, we know that the ring systems are full of dust and ice, but they've also got larger objects that are referred to regularly as moons.
It's interesting. This was one of the exact questions that came up in the Q&A night, the Science in the Pub night that we had on Lord Howe Island at the Dark Sky Festival.
Well, that was Martin. He was there. No, he probably wasn't. Carry on.
Might have been. There was a Martin there.
Was Did he have a British accent?
No, he's quite Australian, but he's not from Heswall. But yeah, interesting coincidence to get the two. And I don't think at the moment there is a limiting size to differentiate between a ring particle and a moon. So it is a great question. How do you define a moon around a planet which is festooned with objects orbiting around it in the form of rings? So we think the rings of Saturn are the debris of probably a satellite that came within the Roche limit of the planet, the Roche limit being the point at which a solid object can't actually survive within that distance, in other words, that close to the planet. And so it broke up into lots of small particles. Probably the biggest ring particles are in the region of 10 meters, because the rings themselves are only about 100 meters thick.
Yeah.
It's quite staggering. And 250,000 kilometers in diameter. So it's quite a contrast. A sort of blade of material in space is the way I've always described it. But some of the smaller satellites of Saturn, and some of them are actually embedded in the ring system. Some of them are measured in single-digit kilometers. So they're not that much more than the biggest ring particles. And I'm not sure that there is a definition between the two. And in a sense, you could say that every solid object within Saturn's rings is a satellite. And so you're then talking about millions or maybe even billions of moons of Saturn. It's a great question, and one that I don't have an answer for, and I perhaps ought to have checked it out in the wake of the question that came at the Science in the Pub, actually Science in the Bolo on Lord Howe Island the week before last when we did the Dark Sky Festival there.
Yeah. He also asked about websites.
Good website.
Well, I just did a quick check, and top of the tree is NASA. For up-to-date solar system information.
Data.
But the other ones that you could try, the skylive.com apparently is very highly rated. Says it offers comprehensive information about the most interesting celestial objects and sets tools designed to support the exploration, etc. The Planets Today is also there, and there's a specific NASA page that you can look up called Eyes on the Solar System, and it provides a 3D solarscape, if you like. So there's a few ideas if you want to chase them up, Martin, but there'd be plenty more out there. There's, just to name a few more, Global Solar Atlas, the NOAA homepage, the Space Weather Prediction homepage, and Planet Labs, just to name a few. So, and they're constantly being updated as far as I'm aware, as things change or as new things come to light. So it might be worth chasing all of those up because they do seem to be highly credentialed, Fred.
Yeah, I was going to say I usually go to NASA when I want the latest figures on this sort of thing. So you've confirmed that and also given a few other options as well, which is good.
Yeah, plenty to look at. There's lots of great sites out there. Just don't go to the ones that start with words starting with F and E. I thought you were going to say don't go to ones that start with space, and I've not seen the answer. That's good advice too. Yeah. Okay. Thank you, Martin. Our final question today comes from Finn.
Hello, Andrew and Fred. It's Finn from Nan in the Adelaide Hills in South Australia, and a happy May the 4th to you as well. I was watching a 40-year-old documentary the other day about a space station orbiting a planet. And this space station, if it was to orbit the Earth, I would like to know how that would affect the orbit of our moon and maybe the orbit of the Earth around the sun, this space station being 150 kilometres diameter with a mass of about 10 to the 15 tonne? I'd like to know. And if for whatever reason this space station happened to destroy our planet, how would the rest of the planets in the solar system be affected by that destruction? One last question to you both is, what was the first animal in space?
It was a dog.
Don't think it was that. It was actually the cow, because it jumped over the moon. Thank you.
Dear, oh dear, Finn. That was probably one of the worst dad jokes I've ever heard. So, but, most welcome on this show.
Yeah.
Oh, gosh.
Yeah, it was good. It wasn't even adequate, that one, was it?
No, it wasn't. No. We strive for adequacy, and he didn't even achieve that. Thank you, Finn. So the substance of his question was you got a space station orbiting Earth at 150 kilometres in diameter or whatever. What kind of effect could that have on the orbit of the moon? And we'll get to the next part of the question after that. Would that have any effect? That's pretty big.
It's big. Well, the critical thing was the mass, which Finn actually mentioned as being 10 to the 15 tons, I think is what he said, which is 10 to the 18 kilograms. And so the bottom line is that's not enough. The Earth just, forget it. So the Earth's 6 times 10 to the 24 kilograms. So it's, what is it? It's 6 orders of magnitude bigger in mass than this space station. And so the other, it's certainly not going to affect the orbit of the Earth. It might perturb the orbit of the moon a bit. Mm-hmm. One of the considerations will be how far away is it from the Earth? And our last question actually pointed to an answer to that. And that is that it would, if it's 150 kilometres in diameter, it has to be a long way away, or else it's within the Roche limit of the Earth, and it would just break up straight away. So I'm not going to guess how far away it has to be, but it'll be a long way off the Earth if it's 150 kilometres in diameter. So that, again, basically mitigates any effects it might have on the orbital dynamics of the Earth. It certainly wouldn't affect the Earth's orbit around the Sun. Might just tweak the Moon's orbit around the Earth a bit. Wouldn't cause the demolition of the Earth. The orbits of the other planets wouldn't even bother to take any notice of it. They are too stable compared with, with a thing of that mass and that far away from the Earth. So it's an interesting thought, and one that I think we can say, yes, you could have a space station 150 kilometres in diameter weighing 10 to the 15 tonnes, and it probably would not affect the status quo terribly badly.
Okay, there you go. And I just did a quick check, but there's not much information about how far space stations have to be away to avoid the Roche limit, but a solid object such as a rocky body with 150 kilometre diameter would have to be at least 141,000 kilometres away from Earth.
There you go.
Probably better off being over 200,000 kilometres away.
Yes, that's the sort of distance I had in mind, something like that. 3 times as far away as the geostationary satellites are.
There you are. Now, he had a second question as to what would happen to the other planets if Earth was destroyed, no longer existed. I think we've been down this road before, and I can't remember the answer.
Yeah, so the other planets would more or less stay in the present orbits. Those orbits would be perturbed differently from what they are now. So perturbations are the gravitational effects of other bodies in the solar system. When you look at the way things are in orbit, you start off with a two-body problem with the sun and your object in orbit, but then you modify it by taking into account the gravitational attraction of other bodies, and it becomes a 3-body problem and then 4-body problem and all the rest of it.
Yeah.
Now, that 3-body problem would change if the Earth wasn't there. Or the N-body problem, I suppose it would be a solar system with 7 planets rather than 8. That would change the dynamics of the planets a little bit, but they would basically remain in their present orbits with just changes to the orbit rather than the orbits being destroyed.
So, in other words, if Earth disappeared, no great loss.
No, not really. I mean, Douglas Adams had it in one, mostly harmless.
Mostly harmless, yes.
That's right.
Thanks to the white mice.
Yes, that's right.
Yeah. I wonder how all the other mice felt about that. It was musculus racism. That's what it was.
It is, yes, mouse racism, exactly so.
Yeah. Thanks, Finn. Great question. We always love these what ifs. So if you'd like to keep sending in questions like that, or if you've got something deadly serious to discuss with us, like, I don't know, exploding rockets and whatever else, you can send them in to us. Just go to spacenuts.io or spacenutspodcast.com. Click on the Ask Me Anything button. You won't be asking me, you'll be asking him, but I'll read it out. Or you can send us an audio question as long as you've got a device with a microphone. You're all set. And while you're there, have a look around. That brings us to the end. Fred, thank you very much.
Great pleasure, Andrew. Always good to chew the fat. I hope we'll do it again soon.
We will. That's Professor Fred Watson, astronomer at large, part of the team here at Space Nuts. And thanks to Hugh in the studio, who couldn't be with us today. He was seeing his dietitian after he reached 10 to the 15 tons. I'm surprised he survived. And from me, Andrew Dunkley, thanks for your company. We'll be back again soon with another episode of Space Nuts. See you then. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.